Hi, in this video we're going to learn how to find vertical and horizontal asymptotes. This is for your rational functions. Now, what is an asymptote first? An asymptote is a line that a curve approaches as it heads towards infinity. There are two kinds of asymptote. There is vertical and horizontal. In a illustration you have here, vertical is of course it's a standing line which tends the graph approaches as it goes to positive infinity. The second example here is the horizontal, wherein it's a flat line wherein it's actually on one and the curve tends to approaches it when it extends on both sides of infinity. If you are given a graph, it is easy to find or determine your asymptotes. It is basically an imaginary line where your graph tends to approach as it goes extend to infinity. Now, how do you find them without the graph? Let's take first your vertical. A vertical asymptote have an equation of x is equal to a, where a is a value that makes only the denominator equal to 0. Looking at your graph here, this becomes 0 if x is equal to negative 3. That's why one of the asymptote is negative 3. But there is another asymptote. It's because positive 1 will make also the denominator 0. Here you have positive 1 makes the denominator equal to 0. Now, how do you actually solve without graphing? Let's have example. Find the vertical asymptote of the given f of x is equal to x minus 3 times x plus 4 all over x minus 2 times x plus 1. What you need to do is to equate the factors of your denominator into 0 so that you can find what values of x will make the denominator 0. To do that, just perform or apply your properties of equation. Add both sides of 2 on the first case. The second one, you subtract both sides by 1. And so you found your vertical asymptote 2 and negative 1. Positive 2 and negative 1 are your vertical asymptote. Let's check your graph. Actually, it's already here. This is the graph of the function. The first vertical asymptote is located on 2. Let me make it bigger. So here it is on 2. And then your second is actually on negative 1. Okay, those are the vertical asymptote of your first example. Let me clear it up. Let's go back. Now, let's have another example. Find the vertical asymptote of f of x is equal to x squared minus 1 all over x squared minus 4. You need to factor x squared minus 4. That should be the case of the difference of 2 squared x plus 2x minus 2. Equate both of your factors to 0. Apply the properties of equation. Minus 2 minus 2 plus 2 plus 2. And so you have your vertical asymptotes on negative 2 and on positive 2. Okay, you can try it for yourself, but checking the graph on the Desmos calculator. Let's have another example. You have here f of x is equal to x squared plus 3x plus 2 all over x squared plus 9. Here, there is a technical problem here. Actually, since x squared plus 9 is not factorable, the function does not have a vertical asymptote. If we're going to check, I actually already prepared the function. It's actually this one. If we are going to click, as you can see, there is no way that this graph can have a vertical asymptote. A vertical asymptote cannot intersect the graph of the function. There is no way. If we're going to zoom in, it does not have allowable location to have a vertical line that it does not intersect the graph of the function. So this function does not have a vertical asymptote. Okay, now let's have number 4. Find the vertical asymptote of g of x is equal to x squared plus 5x plus 6 all over x squared minus 9. We can factor x squared minus 9, which is x plus 3 times x minus 3. But remember to consider your numerator. Your numerator is supposed to be factorable as x plus 2 times x plus 3. That's why we need the knowledge on your factoring and simplifying your fraction, your rational expression, because we need it here. We could actually cancel x plus 3. For your vertical asymptote, in this case, we will just deal with x minus 3. And so we equate x minus 3 to 0, add both sides by 3, and your vertical asymptote for this function is only on x equals to 3. Okay? Now, what about horizontal asymptote? A horizontal asymptote of a function have an equation y is equal to b. B represents the y-intercept. It's kind of uniform symbol. So a vertical asymptote for this case is on 2, the other one is on 1. Now, how do you solve for horizontal asymptote without the graph? There are 3 possible cases. The case is dependent on the value of the degree. If the degree of the polynomial function on the numerator is less than the polynomial on the denominator, we have this first case. The second case is when the degree is equal, or the degree on the p of x is greater than the degree on the q of x, which is the denominator. What if p of x is less than? If the degree of p of x is less than the degree of q of x, then the horizontal asymptote is y is equal to 0. Therefore, the asymptote is located at x-axis, or the horizontal line y intersecting at 0. If the degree is equal on both numerator and denominator, then the horizontal asymptote is found by solving y is equal to the leading coefficient of the numerator of the polynomial function divided by the leading coefficient of the denominator of the polynomial function. We will have example on this. The last case, if the degree of the numerator polynomial function is greater, then there is no horizontal asymptote. Okay, we will go back to this whenever we need to. Let's have your first example. Find the horizontal asymptote of the function 3x squared all over x squared minus 1. Now, based on the cases, it belongs to case B. Case B is saying the degree is equal on both numerator and denominator. That is, therefore, if the degree is equal, then we follow the division rule. The leading coefficient on the numerator is 3. The leading coefficient on the denominator is 1. Therefore, horizontal asymptote is found by equating y is equal to 3 over 1, or just 3. Okay? Now, find the horizontal asymptote, another example, of g of x is equal to 2x squared plus 4x plus 1 all over 4x squared minus 3x plus 2. It's the same case with the first example of the horizontal. We have the same degree. We will compute or divide the leading coefficient of numerator all over leading coefficient denominator, which is 2 divided by 4. You need to simplify and you're done. It's 1/2. That's it. You can check the function on your calculator, but it should be on 0.5 of y. Okay, or y of y-axis. Next, number 7, find the horizontal asymptote of the given 4x all over 2x squared minus 1. It's the case A, wherein the degree of the numerator is less than the degree of the denominator function. So, if that is the case, the asymptote is y is equal to 0. There's no solving involved. If you notice that the 1 over 2 or 3 over 5, the degree here is 3, the degree here is 5, your asymptote is 0. It means the y or the asymptote is on the x-axis or on the y intersecting 0. A horizontal line intersecting 0 of y. I think this is the last example. Find the horizontal asymptote of the given h is equal to 4x to the power of 5 plus 3x all over 7x squared. This is the case of letter C, wherein the degree of the numerator is higher than the degree of the denominator. If that is the case, again, there's no solving involved. There is no horizontal asymptote. Let's check. It's actually prepared on your Desmos. This is it. We are expecting a flat line, and this is the graph. There is no way that you can draw a flat line wherein the curve tends to approach as it extends to positive infinity or to negative infinity of x-axis. Okay? There is no horizontal line that could possibly make it tend to approach. Okay? And that's it. In summary, there are two types of asymptotes, vertical and horizontal. To find a vertical asymptote, find where only the denominator is equal to 0. To find a horizontal asymptote, there are 3 cases. Given the function p of x all over q of x, if it's based on the degree. If the degree of q of x is less than degree of q of x, horizontal asymptote is y is equal to 0. If the degree is equal, then the asymptote is found by dividing leading coefficient of p of x all over leading coefficient of q of x. The last case, if the degree of the p of x is greater than the q of x, the function has no horizontal asymptote. Okay? If you need to review, you can watch this video again. Thank you.